In these problems, we're looking at functional groups as well as drawing structures that satisfy various criteria. In part A, we're looking for a compound that has a chemical formula of C9H14. Now, if we just try and draw a 9-carbon molecule, such as that one, if we count up the number of hydrogens, we'll find that we end up with C9H22. So that's a lot more hydrogens than what the problem here is calling for. So we need to somehow get rid of 8 hydrogens in this problem. But notice the problem also specifies that we can't have any pi bonds here. So pi bonds are usually an easy way to remove hydrogens, but since we can't have that, the only other way that we can do it is to add rings to our molecule. So every time we close a ring, that takes up 2 hydrogens. So if we do that once, we've gotten rid of 2 hydrogens, and we've made this C9H20. A second ring would get us down to 18. Third ring gets us to 16. And finally, a fourth ring gets us to our final formula of C9H14. In our second part here, we're looking for an aldehyde. Recall that's a carbonyl bonded to a hydrogen and an R group. An aromatic ring. And then a thiol. A thiol being carbon bonded to an SH. So if I were approaching this problem, I would start out by drawing an aromatic compound that has an SH and an aldehyde. But we know at this point we're not done because we've only used 7 total carbons and we've only used 1 of the oxygens. So to start simply, I'll just put 3 more carbons in here, and then we'll put another oxygen in. Now at this point I know I have the right number of carbons, oxygens, and sulfurs. The question is, do we have the right number of hydrogens? So we have 1 here, 1 here, that's 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And if we look at our problem, we're calling for C10H12, so we have the correct number of hydrogens, we have the right number of, we all have all the correct functional groups, and therefore we're done.